Hello friends, welcome back to the world of 4G. Today we will discuss the function of MAC scheduler module and physical channels.
Previously we have shown the different functions of MAC layer, with the analogy of transportation mechanism used in logistic companies. In addition to that, MAC layer also contains MAC control, which performs two important operations. 1. As we know, during transmission and reception of data, a lot of power is consumed by the handset. So, in order to save power, the user equipment does not stay awake all the time. In idle mode, it wakes up at fixed intervals to receive data through paging alert messages. This is called discontinuous reception or DRX operation. Now, this paging alert messages are neither processed by MAC layer, nor by hybrid ARQ layer, since paging signals are retransmitted on fixed intervals, based on discontinuous reception or DRX inactivity timer. So it does not depend on hybrid ARQ ACK or NAC response. 2. MAC control is also responsible for the alignment of the uplink timing and power headroom reporting. The most important function of eNode B is to allocate resources dynamically. This function is handled by MAC scheduler module of MAC layer. Previously we have discussed that MAC layer has to handle 1. Hybrid ARQ retransmission control, 2. Logical channel multiplexing and priority handling.
These functions are actually handled by MAC scheduler module. In addition to that, it has to dynamically decide modulation scheme. The MAC scheduler gets information of the instantaneous radio channel quality from user through channel state information messages, in which it sends the channel quality report. Based on channel quality, it decides which modulation scheme is to be used. Now, the data in downlink shared channel or user plane channel contains user traffic which needs to be carried out to user, irrespective of channel quality outside. If the coverage is poor, the network will use QPSK, else it will use higher modulation schemes such as 16Com, 64Com, etc. But the signaling channels need guaranteed delivery. That is why they use QPSK, as it is considered the most robust modulation scheme.
MAC scheduler module also has to decide which are the terminals to transmit, the set of resource block upon which the downlink shared data for the mentioned terminal would be delivered, the selection of transport block size. These three functions are implemented in physical layer. So, as you can see, MAC scheduler module takes most of the decision. Rest just follow accordingly. That is why it is also called as the brain of LTE. That brings us to our last and most complex part, that is physical channels.
The transport channels such as paging channel and downlink shared channel are mapped into physical downlink shared channel. It is used for carrying user traffic and as well paging information. The broadcast channel and multicast channel are mapped 1-to-1 physical broadcast channel and multicast broadcast channel. Similarly in uplink, the transport channel such as uplink shared channel is mapped onto physical uplink shared channel, and physical random access channel is used for random access functions. Now, consider you are an user, you received some physical data from a node B through physical channels. But you don't know in which resource element the downlink shared data is hidden or which demodulation scheme to be used. That is why L1 and L2 control signals are used. They carry downlink control information, which contain relevant information on how to process the physical data. It is just like the record submitted by Team C, based on which the items are extracted at receiving end. The various control signals used here are physical downlink control channel. This channel carries the control information about the data being transmitted on the current subframe and the information about the system information block, which user need to use for the transmission of uplink data. That means it is mandatory for the user to decode it successfully if it wants to send some data or receive something. It also provides uplink power control information and hybrid ARQ info. Physical control format indicator channel, as the name implies, this channel informs the user about the format of the signal being received. It indicates the number of OFDM symbols used for the PDC-CH, whether 1, 2, or 3. The information within this channel is essential to decode PDC-CH, because the user does not have prior information about number of resource to be used in OFDM grid. Physical hybrid ARQ indicator channel, it carries the hybrid ARQ ACK or NAC signal, indicating whether a transport block has been correctly received. The control signal used in uplink is physical uplink control channel, which is the counterpart of PDC-CH in downlink. If we notice here, there are no transport channels corresponding to control channels.
So far, we have seen the function of logical, transport and physical channels. But these MAC PDUs or the transport blocks, which are being delivered from MAC layer to the physical layer, undergo a lot of digital signal processing before being sent to the air interface as RF signals. Let us understand them with the help of block diagram. CRC attach. A cyclic redundancy check, CRC added to every transport block for error checking. If after adding CRC to the transport block exceeds the maximum block size, then it is segmented to smaller code blocks, and individual CRC is added to each code blocks by a turbocoder, which is called as code block segmentation. Channel coding, it's a turbocoding step, whose job is basically converting 1-bit input to 3-bit output as it goes through the turbocoding processor. It means the coding rate is 1/3. Rate matching, in simple words, the output of the turbocoder goes through detailed process of interleaving, bit collection, bit selection and pruning, and ultimately generates an encoded bit stream. These coded streams then go through scrambling process. After that they are mapped to correct modulation scheme, which is decided by MAC scheduler, as discussed earlier. After a pre-coding process, finally the bits are mapped to resource elements and then goes for OFDMA process. In uplink the same physical layer model is used, only the last OFDMA block is replaced by a CFDMA. Once the signal processing is complete, the resources are finally ready to be transmitted in air interface.
That brings us to the end of channels used here. To summarize it all, logical channels tell what is the type and purpose of the data, such as paging, broadcasting, etc. Transport channels decide how the data is going to be transmitted. It allocates the transport block size and dynamically decides the modulation scheme that is to be used. Physical channels know where exactly the resource elements are located. It handles the signal processing and thus it knows how exactly the data is going to be transmitted. So in a nutshell we can say, we cannot transmit the data without knowing where to transmit and how it should be transmitted. Also, we cannot decide how data should be transmitted without knowing what is the data. So in hierarchy of 4G protocol stack, first logical, then transport, then physical. So friends, thanks for making it to the end. In our next video we will be discussing MIMO, multiple input multiple output, and carrier aggregation, where we will also discuss how throughput is calculated. You can post your doubts in the comments section. Don't forget to share it with your friends. Happy learning!